You see that? That is my neighbor's roof, and for some apparent reason they seem to have a Maxwell-Boltzmann distribution diagram on it. A Boltzmann distribution diagram is directly connected to collision theory and activation energy, which I will attempt to explain in under 3 minutes. Collision theory has two main concepts. The first one is chemical geometry and the second one is activation energy. Let's start off with chemical geometry. The first part is correct chemical orientation, which can be demonstrated using a balloon and a needle. In this case, our reaction is to getting the balloon to pop. But in order to do this, the needle has to have correct chemical orientation. This means it can't be on the side because then a reaction occurs, and it can't be backwards because then no reaction occurs. But with the pointy side of the needle facing the balloon, a reaction will occur. So what is activation energy? Well, it's the least required amount of energy in order for a reaction to occur. Here's also a great example of activation energy. If I just throw the needle lightly at the balloon like this, no reaction will occur, since I don't have sufficient energy. But with sufficient energy and the correct chemical geometry, the balloon will pop. So how does all of this connect to the previously mentioned Maxwell-Boltzmann distribution diagram? Well, the distribution diagram quite well displays how many particles react in a reaction. The axes in a Maxwell-Boltzmann distribution diagram are labeled as follows. The y-axis is number of particles and the x-axis is energy. In a reaction, the average of all of these particles' energy is what we call temperature. But however, in a reaction, the majority of the particles will have a lower energy, and a minority will actually have higher energy that surpasses activation energy. So only a minority of the particles will have enough energy to actually react. This can be demonstrated by me throwing 100 needles at balloons. Only maybe 5 of my needles will have enough energy to actually pop balloons. But what happens when we increase temperature? Well, that means that the average of all these particles will increase. And this can be demonstrated by me throwing 100 needles, but I've gotten stronger. Then the average energy of my throws would be higher compared to when I was weak. This would also mean that more particles have actually reached activation energy. The second thing is that the particles will start to move faster, which will result in more collisions and hopefully more successful collisions due to correct chemical geometry. My name is Oscar Gustafsson and this has been Collision Theory in under 3 minutes. Thank you.